Hello everyone. Now one of the important part in the stoichiometry, that is limiting reagent concept. The meaning of limiting reagent is in the reactants the quantity which is given limited, which is less quantity, that decides the product quantity. This topic we will come across after law of conservation of mass, law of constant proportions, law of multiple proportions, law of reciprocal proportions. There are four laws. The chemical equation, the quantitative aspects of the chemical equation governed by four laws. Just now I told you, right? To understand this limiting reagent, the meaning, let us see. Suppose A plus B gives rise to some product C. If they are in constant proportion, fixed proportion, then there is no excess, there is no limited quantity, there is no leftover quantity, directly product conversion takes place. For example, a basic equation we have taken, that is C plus O2 gives rise to CO2, carbon 12 grams, oxygen 32, carbon dioxide will be 44 grams. In this equation, after the process, there is no leftover carbon, there is no leftover oxygen, zero remaining quantities, only carbon dioxide product formation takes place. Similarly, next I will ask you a question. If carbon having 6 grams is given, then how much product, two questions, how much product formation takes place and how much oxygen required. Okay, as simple figures we have given 12 becomes 6 grams, that is half. So definitely oxygen 32 will become half, 16 grams. 6 grams reacting with 16 grams of oxygen, it will give 22 grams of carbon dioxide. It is easy, isn't it? 22 grams of oxygen. If the given quantities are irregular, then how to calculate the produced product, and how to calculate the opponent quantity? So 10 grams and 5 grams. There is no logic. We should do the paperwork here. Paperwork is required. First step is find the limiting reagent. Which quantity given less apart from the constant ratio? This is a constant. This data never change. For the CO2 conversion, CO2 gas production, there is no other ratios. This 12 grams and 32 grams, it is fixed. It won't change. This ratio never change. Okay. It's a constant. That's what law of constant proportions we call. Law of conservation of mass and constant proportions. Two laws you can see in this topic. So first step is find the limiting reagent. How to find the limiting reagent? We will take the basic expression as usual. You can here you can see carbon 12 and oxygen 32. Now carbon 10 grams requires how much O2? Of course, given is 5 grams. Actually required how much? Actually required unitary method. 10 into 32 by 12 will give 26. Oh, we got it. So required quantity oxygen is 26.66 approximately. But given is only 5. Given less, required more. Given less, required more. It indicates what? Oxygen less. We have quotated it is less. So that is a limiting reagent. Oxygen is the limiting reagent. Then first step is over. We have calculated the limiting reagent. Then limiting reagent is the left side. Product side is in right side we will write. We will take the standard quantities again. Standard quantities 32 will produce 44. Then 5 grams produce how much? Unitary method 6.875. Right? So this is the way limiting reagent helpful. Limiting left, required quantity right side. Even we can do the third model question also. How much carbon as it is excess, no? How much excess? How much excess? How much consumed can be calculated? Again the same pattern. Limiting reagent we will write in the left side. Required quantity we will write right side. We will first step will be standard quantities 32 and 12 is the standard. See 32 and 12. Then 5 grams oxygen will take how much carbon? This is what the carbon taken. 1.875 grams carbon will be consumed. What is the leftover? Remaining carbon, 10 grams, 10 grams minus that 1.875. That will be the carbon leftover. Yes, this is the advantage of limiting reagent. This limiting reagent we can do not only with the grams, even we can proceed with the moles. If all quantities are gases, we can proceed with the volumes, milliliters, liters also. Okay, fine. Thank you.